You got to make a choice. And the choice is what? The party or school. Then go there. But the last thing I'll do is, when people try to come and go, well, I'm not passing. Okay. What do you want me to do? Do I really have to do all this stuff? The answer is what? I can't make you do anything. And I won't make you do anything. It has nothing to do with me. Just give the test, and it has it in the private. That's the answer. That's the answer. No big deal. It's not a big deal. So I think personally, where people need to practice at this point isn't necessarily. I think from my experience, I think people need to take a look at finding critical values for the t distribution. Once you get that, it's like the other thing, which is finding the hardest part with all this, is finding the critical values. Because guess what? You get somebody a format, hey, identify mean, it says mean. Identify standard deviation, it says it. Identify sample size, it says it. The real work for people is right here. This is where they really have a problem. And from my experience, estimation is where people do the best. They usually do the best on estimation. Because it's not that difficult. It's just going through the process. So the hardest part for us is going to be looking for those t values. So what we'll do is work on that, determine the t value. Right? This is in your error formula, t alpha over 2. That's the t value. Also known as this is also known as a critical value. It's actually, they don't use critical value language until the next chapter, but that's what it is. Okay? So all you need is 2 pieces of information. So I'm going to say this to you. Fill in the blanks. N, df, now let's do this. Let's really get, say, alpha, 1 minus alpha, t alpha over 2. N 6, 18, 20, 22, alpha. Let's say 1, yeah. How about this? Let's make it a real exercise. Wow. So what's called alpha? Let's say the 95%, 90%, 99%, 95%. Okay? So you're going to fill in the blanks. Degree of freedom. Do it this way. What you need will help you. This is the chart. Sorry for changing it so much. But we're here to confuse you because that's the whole idea. So notice what you have to find. Degree of freedom, alpha. Once you get that, determine what your critical value is, t alpha over 2. Okay, so we'll give you some time to do this. We'll take a little break after that, so I could go get your exam. I'll just go get your exam to pass back to you. Okay? I'll be back at 12:10. Give you some time to do this. Be back at 12:10. We'll go over this, and we may go over another one. You ready, Eddie? You ready? Okay, let's take a look at this here. We're going to look at the t-table again. Degree of freedom versus your alpha. Okay, so that first row here, if n is 6, what's the degree of freedom? 5. Okay. If the confidence level is 95%, what's alpha? Well, it's 5%, which is 0.05. Is that true? So you're going to look for the fifth row and the 0.05 column. What do you guys see there? 2 point what? 2.571. Second problem, what are you guys going to look for? What's the degree of freedom now? Well, if n is 18, you're going to look for what, 17? What's alpha? Well, if the confidence level is 90%, alpha is what? 10%, which is 0.10. So you're going to look for 0.10 column, 17th row, and what do you guys see there? 1.740. Okay, what row are you going to look for now? N is what now? 20. Degree of freedom is 19. So what's alpha? 1%. What's that? 0.0 what? 1. .01. So what do you guys see there in the 0.01 column in the 19th row? What is it? 2.86 what? 1. Okay, finally, if n is 22, what's the degree of freedom? 21. What's alpha? It's 5%, which is 0.05. So where's that going to be at? 2.080. Okay. So these are the critical values associated with a small sample, and that's actually the hardest part for what you're doing. Everything else you're plugging back in. Okay, so far we've estimated a proportion. We've estimated a mean. And what do you think we're going to estimate now? Variance. Variance and then standard deviation. If we estimate variance, we estimate standard deviation. Okay? So let's write that format down for you now for this problem. If we're going to estimate now variance. Okay? Let's write this down. Here's your format. N minus 1 s squared less than sigma squared less than n minus 1 s squared. This is a little different. And you get a chi-square right over a what? Chi-square what? Left. Now, this is your true variance. this value is the what? That's your sample standard deviation. So is this. This is the what? Yeah, it's a sample standard deviation. And then you got n minus 1 and n minus 1. This is really your degree of freedom value. Is that right? So what you really have new here is this chi-square r and chi-square l values. Okay? These here, this is known as a right critical value, and this is a left critical value. These are chi-square values. Okay? And so what we have to talk about now is, because when you take a sample, you can get the sample variance. When you take a sample, you can get the sample size. That's n. So n is a sample size, n minus 1 degree of freedom, s squared sample variance. Oh, s is a sample standard deviation. S squared is a sample variance. Okay, so I might have said it, but I don't think I wrote that down. All right, here we go now. Here's your chi-square distribution. Okay? It's spelled CHI, and the power 2 is where they get the square from. So it's the chi-square distribution. Okay? The chi-square distribution is a positive distribution, meaning that it doesn't have any negative values, chi-square. And so if we're going to look at now finding critical values here, this here and this here. This is the left chi-square value, and here's the what? Right chi-square value. Okay, so now be careful here. How I remember it is that when I look at the chi-square distribution, that first value is on my left. This value is on my what? Right, because this is my left and this is my right. Is that true? However, when you use this format to estimate variance, the chi-square r value is on the left. The chi-square l value is on the right. So it switches in the format, but it doesn't switch. It makes sense in the picture. It's only in the format that it switches. Here, this picture, it doesn't. Okay? So the task now is for us to determine these critical values, because that's the hardest part. Okay? So what we're going to do is this. That's what we're going to do, the same game, but this time we're going to determine critical values for various sample sizes, and then we're going to look at an application. So let's determine these chi-square values. Okay? You're going to have n, a sample size. Associated with every sample size, you'll get a degree of freedom. And then you get a chi-square L value, and you get a chi-square R value. Okay?